remember how to find a half-life, what equation you used, anything like that? Anyone? Kurt? Yes, no, maybe? Continuously compound interest. Yes. And we use that because in the real world, interest doesn't stop and compound once a month or once a year. It's continuously compounded. So an element, its decay is not, it's continuous. So how we work a half-life problem, it's been a while. Suppose a particular radioactive element has a half-life of 600 years. How much of a 50-gram sample will remain after 125 years? Well, the first thing I note is that it has a half-life of 600 years. A half-life means that in 600 years, half of the sample will be remaining. Chemistry people, this look somewhat familiar? You've heard / seen it sometime? Do what? You don't do any half-life stuff in chemistry?
Do.
You probably just use the formula, which I'll show you momentarily. We can solve this for R. Take the natural log. This would be 1/2, wouldn't it? Would it have mattered how much I started with? Wouldn't that be a half no matter what? Which is probably somewhere related to the formula, if you've ever seen a formula. Natural log of a half divided by 600 will give you the rate, which will be a decimal. Joe get there faster than I did. What'd you get?
-0.001.
Does it make sense that that's negative? Decaying, so it would have to be. Now, keep in mind, even though I am writing a 3 decimal place round here, make sure that you store that value in your calculator because, especially with exponential growth and decay, tiny changes in percentage can make huge differences long term. So you will want to leave that as a stored decimal in your calculator when you go work the rest of the problem. The actual question was, how much of the 50-gram sample will remain after 125 years? How would I do that?
Plug in -0.001 for R.
Good. And what in for T? So this was an example of a half-life problem that you would have seen in pre-cal or in chemistry. Today we're going to see how that relates to differential equations. What do we get?
44.125.
I think it was grams. The beauty of the half-life problems in differential equations is half the time you can work them as pre-cal problems if you recognize them as such. However, you have to know how to work the pre-cal part of them, so that's why we started here. Okay. So, a half-life is a process that can be described as exponential decay. As time passes, the change in the amount of material is directly proportional to the amount of material contained in the sample. So not surprisingly, that can be written as a derivative. So the rate of change in the amount of material, which I would call dy over dt, is directly proportional to the amount of material. Well, if y is the amount of material, then it's directly proportional to that. So I can write it as a constant times y. So let me review quickly direct proportionality. There's a lot of pre-calculus words thrown around in this. Direct proportionality is two things that are related. When one increases, the other increases, but maybe by a different constant. So a recipe is a really good example of direct proportionality. The amount of eggs you use and the amount of flour are directly proportional. They're not the same amount, but they're directly proportional. If I multiply the flour by 3, I better multiply the eggs by 3. Does that make sense? So that's what direct proportionality is. So this is the exponential growth / decay as a differential equation. I could solve this differential equation. I am going to do that. Is k a variable? It is a constant. So I end up with 1 over y dy equals k dt. You may recognize this. We actually did it a couple days ago, this exact problem. I am solving for what's called a general solution. I don't have an initial value. This is just a generic equation. Can I get y by itself? Good. E raised to both sides. I get absolute value of y equals e to the kt plus c. So I have y is plus or minus, and we did learn we could write this as e to the kt times e to the c. And isn't e to the c just some other constant? I'm going to call it p. Just for fun. Everyone agree? So a good calculus student, who's a good lazy math person like the rest of us, if you saw this differential equation, couldn't you just recognize it as a PERT formula problem? That's a good idea. Maybe you should try it. Okay. We are going to practice a little bit on the wording of proportionality. On writing a differential equation based on those words. So this one says, write a differential equation that matches the given situation. The number of bacteria in a culture grows at a rate that is proportional to the number present. So let's give some variables. What is a variable that I've got here? You can make one up. B. Okay, number of bacteria, B. Everyone agree that's a perfectly good variable? So the number of bacteria grows at a rate. What kind of variable do you use for a rate? Kind of variable.
What letter or?
She already picked B, so we're stuck with B.
Oh, I thought she would pick
dB dt. Why would that be a rate? Amount of bacteria over time. So a differential is a rate. Makes sense. So the rate of bacteria growth is proportional. So that means we're going to have a constant times something to the number present. Well, isn't the number present, didn't she already call that B? This is another PERT formula problem, isn't it? Okay. So it wanted me to write a differential equation. I did. Okay, this one's a little different. Try this one. Write a differential equation that models this one. Pause. Okay, what variable did we decide to use? F. Okay, for like Fahrenheit maybe. And we have the rate of the change of temperature. Most people probably use T, which works great too. Capital T, but I could see why if you didn't want to use a capital T and a lowercase t, why you might use something else. Is proportional to the difference between its own temperature and the temperature of the surrounding medium. The temperature of the surrounding medium, is that a constant or a variable?
Constant.
Probably a constant, unless you've got a very, maybe in this room it's not a constant, but in most rooms you got 70 degrees or whatever it may be. So that is a constant. A lot of times people will call it T subscript 0. You could just call it T, but it is a constant. This differential equation is actually the differential equation for Newton's law of cooling. Have y'all ever seen Newton's law of cooling? If you solve this differential equation, you get Newton's law of cooling. We're not going to do that. It just asked us to write it. We did. We're done. Interesting nonetheless. The number of deer in a population grows at a rate that is inversely proportional to the square of the number of deer present. This almost feels like we're in a geometry class for a moment, doesn't it? Talking about proportionality, direct proportionality versus inverse proportionality. Do y'all remember those words from geometry? And then I think you learned them again in Algebra 2. I think I taught.
What series in physics?
Do what?
What series, like inverse proportion?
In physics. Physics and calculus is practically the same class. Different spin on things, yeah.
All the vectors and everything.
Mm-hmm.
I can't believe physics doesn't have like an AP though.
I think we used to, and it just didn't have enough people.
Now there's a ton of people in it.
Well, it's that you have to fit them all in a class, and it kind of conflicts with calculus. Greenwood's just kind of, even though we're big, we're kind of small. Conflict of scheduling and I think science always likes theirs, which you could do a 1 hour, but
I don't understand why calculus 2 isn't 2 hour.
well, where no one could take it, because the sciences are 2 hours. So. This is the only.
You just use science and math class in the day.
Yeah. This is the only school I've ever been at that the science classes were doubled like this. So it's
We
nice.
got a petition, sign it, and get people to change it to math class.
We have it'd be a hard sell because they'd say, well, your scores are fine.
So what they could do with it.
Why do you need an extra? Why do you need an extra hour? I'd like it otherwise. Have less preps.
Do more depth.
Yeah. Mm-hmm. Okay. What do you use as your variable? D. So D. Big D, like this. Oh, yeah, you're right. Perfect. Times what? Very good. Inversely proportional is very similar, except it's 1 over the variable instead.
So what is K?
Some constant. Now, in the very first example, it was your rate. It it ended up being the R in the PERT formula, but it's just some constant that we don't know.
So why do you?
Because these aren't equal. If the rate were equal to 1 over d squared, they'd say the rate equals 1 over d squared. But they are inversely proportional, which means they are equal except for a constant.
So if we see proportional, that means
K times something. Or you could use a different letter if you don't like K.
but we can't use C, can we? Since
Right, because you're going to use a C later. Unless you use a C first, and then you can use a K later. I suppose no one would complain. It would be untraditional, but... Okay, I'm going to get you this packet so that you can write this problem down.
So are we done with that last packet we just did?
For the most part, we'll keep it to study for the test. We essentially have three. We haven't done any new calculus except for differential equations. But we've done a lot of new applications.
Isn't that all we're doing? Just 3?
Yeah, this is the last one. We got one more worksheet. Other than that, almost finished the unit. The only thing we have left to learn is slope fields.
Say 6 is harder than 7?
No, 7's harder. I think 7's harder. Yeah. Yeah, it's the area volume.
That's just longer, like longer and quicker.
No, it's volume was better.
You thought volume was a little tough?
Volume?
Yes, but you want to learn it better.
Is that the washers?
Yeah.
Okay.
It's the thing you could stand to actually learn well.
Yeah.
You have a somewhat idea of it, but it's probably not.
It's just the videos.
Yeah, that will help when you, because I have some things to put in your hands to look at. It helps. Okay, let P of t represent the number of wolves in a population at time t years, where the population, P of t, is increasing at a rate directly proportional to 800 minus P of t, where the constant of proportionality is k. So they did tell you to use k on this one. For simplicity's sake, I'm going to drop the t on the P of t and say dp dt is k times what? And again, just for simplicity's sake and my solving purposes, I'm going to drop the of t for now, because to me it's a place you could accidentally think you have an extra variable there. But remember, P of t just means the y value at time t. So.
And they won't let you long something.
When we get done, we can write P of t equals. How do I solve this differential equation? Separate the variables. Okay. I could put the k anywhere I want to, but remember, it's easier if it's not a fraction. Integrate both sides. I will tell you, this last year when I taught this, this was one of the most commonly messed up anti-differentiations, because people tried to do it in their head, which a lot of people can do it in their head. But when you see something that looks like that, what should you try if you don't just know the answer? U substitution, right? Everyone agree that that's a U substitution? I have a denominator that's not just p. If it were just a p, I could just do natural log. Since it's not just p, I better do a U substitution. So I'm going to let u equal 800 minus p. du equal negative dp? So negative 1 du equals dp. So mainly, I really just needed to know that when I do the logarithm, I get a negative 1 out front. And some of you can get away with doing that in your head, but be careful. A lot of people forget that negative. So I get the integral of negative 1 over u du, which is negative natural log of the absolute value of u, which is 800 minus p, equals kt plus c. Divide by the negative 1. That's not the only way you could deal with that negative 1, but I think it is the easiest. Actually, I might not want to do that first. What should I probably do first? Before all of find c. Put 0 in for t and 500 in for p. Natural log of 300 is negative c, or negative natural log of 300 is c.
If that wasn't a 0,
Then you'd have to subtract it over whatever number it was. A lot of times they do give you a 0 because it makes your life easier. So we have natural log of 800 minus p equals negative kt. And I probably putting the negative in made it a little harder than it should have been, but it is minus a negative. Would you agree with that? So it's plus natural log of 300. Questions about that so far?
why can't you just leave the negative?
You could. At some point you need to get rid of it, but I probably wouldn't have. If I really messed up by doing this next step, I probably would have plugged it in here and then gotten rid of the negative down on this step. I just was working too fast. 800 minus p equals e to the negative kt.
Times.
Good. Times e to the natural log of 300. Since this is open response, you don't have to do this step, but it will make your life a little easier. So you get 300 e to the negative kt. I do need to decide if that's plus or minus so that I can get rid of these absolute values. So I'm going to go up to my initial condition quickly. If I plug in 0, I get positive 500. So if I plug 0 in here, what's anything to the 0 power? 1. I get positive 500, correct? So what would need to happen? Let's just put it in. 800 minus p. If this were 1, to get p to be positive 500. Let's try it really quick. This would just be 300, right? So 800.
P where it equals, or
Yeah, p is 500.
Um,
Would the positive here be what you get if you put in a positive 500? Yeah. Looks good to me. So we're going to leave it positive. I thought about it. I do want p by itself. Last step, divide by negative 1.
why did you drop the absolute value in the 300?
How else am I going to get p by itself? Oh, you mean up here on the natural log 300? Is 300 positive or negative? So absolute value non-absolute value. It's the same thing. So I just didn't need it. Good question. Plus 800. Okay. So that one was quite a bit of work. That is part A. Most likely, on an AP problem, that is worth 6 points. 6 out of 9. So it's a lot of work, but you get it's a lot of big reward. Most of my students got really excited when they saw a differential equations problem. When we start looking at the rubrics on these, you'll know exactly where you're going to get a point. You get 1 point for separating the variables every time. You get 1 point or 2, depending on the difficulty level, for the anti-differentiation. You get 1 point for putting plus C. It's awesome. So make something up and put plus C after it and get a point there. And then you get another point for solving. And so if you solve incorrectly, you've only lost a point. Would you agree most of the difficulty level came from here down? That's part of the reason I make you find C early, because you would have gotten 4 out of 6 at least if you just made it to C. So lots of points to be picked up on a differential equations problem. The other 3 points would probably be 2 here and 1 here. I don't remember. We'll see this rubric in a few days when we look at the rubrics, but probably something like that. But generally 6 points for just solving a differential equation. So those are nice. Okay, then it says if P of 2 is 700, find K. That's not even a calculus problem, is it? That's an algebra problem. If you did not know how to solve this differential equation, try putting a differential equation down, or solution down, and working parts B and C. You won't always get the points for part B and C if you oversimplify, but if you had any exponential function and you solve using that, you will get the points for part B. So I'm going to put 700 in for P, which also means if you have something wrong here, you will still get the points. Does everyone know what I mean by that? For part B. Negative 300 e to the negative k times 2 plus 800. So I get negative 100 equals negative 300 e to the negative k times 2. Divide by negative 300, I get 1/3. And by the way, not all differential equations are this complicated. This one had a lot going on. Natural log of a third equals negative k times 2. So natural log of 1/3 divided by negative 2 is k. If this is a non-calculator problem, I'll leave it like that. The one thing you will want to know is whether this number is positive or negative. You're going to need to know that for part C. And I'm going to pretend it's non-calculator, and I'm going to reason through that. It is already a negative, so negative, negative, I just get natural log of a third divided by 2. Does everyone agree with that?
So is this C, like you're starting C right now?
Yeah, I'm starting C, because all it said on part B was to find K. I did, I'm good.
So why are you dropping negative?
This was negative, and this was negative. So negative, negative makes sense. I now need the limit as t approaches infinity. The only way I can figure that out is to know if this number is positive or negative. I have to know that. A logarithm is positive if the number you're plugging in is greater than 1. If the number you're plugging in is less than 1, between 0 and 1, it's negative. So that natural log of a third is negative. If you don't believe me, type it in. But anything less than 1. Think about the graph of a logarithm really quick. Do you agree? Before 1, it's below the x-axis. So this is a negative value. if I'm doing the limit as t approaches infinity, that negative value moves the e to the... What's a negative exponent do? It moves it to the bottom, right? So I'm dividing by a really big number. So this whole term goes to 0.
So wait, why'd you drop the negative on the k key?
The negative and the negative on the negative 2.
So
Probably good. Here, there.
wait, why would it be both negative?
Well, this was negative here, and this answer was negative.
So, but then you plug it back into the normal k, so that should be a negative k. So would the 2 on the bottom be negative still?
I changed it to plus a positive. So this
So
is
you put negative k and then you changed them both to...
right, because the negative divided by the negative makes a positive. So that one was also tough. I will tell you, this was probably a 1-point problem. This limit was probably a 1-pointer. The bulk of the points on this problem came from part A. Again, 6 out of the 9, probably. Almost always. Okay, your homework is 2, 3, and 4 on the AP packet. Unit 6C. Tomorrow. It's 3 of them. You do have 10 minutes left in class. Work.